Welcome back to my course, the Industrial Biotechnology. Now, this lecture will cover something new product, that is the another type of single cell protein, that is the spirulina, because algae nowadays lot of use for different purposes, because we have algae can be used as a food, as a pigment, for medicinal purpose. It has tremendous potentiality that we have in the market. So I have chosen that one product with largely market, and the research work has been carried out for quite some time. The one that is the spirulina. But spirulina production that we know, and the spirulina represents a group of blue-green algae, what we call is cyanobacteria, referred to dry biomass obtained from the species of Anthrospira platensis and Anthrospira maxima. This is the name of the organism that is used, and it can be consumed by human as dietary supplement and can be used animal feed because it has the high nutritional value. The use of spirulina dates back 16th century and used the Aztecs and other Mesoamerican as food source. Apart from being used as a food source, this primitive life form is responsible for producing oxygen in the atmosphere, allowing the life form to develop. Now here I want to point out one very interesting thing, that we have one project on this for algal production, that is food, feed, and fuel production. And this is kind of Indo-Denmark project we had, and we work in details on this project. And we have collaborator in India, we have collaborator from Denmark. In India, we have this Indian Agriculture Research Institute. They have National Center for Cyanobacteria. They work with us, and also in the Madurai we have the antenna. There is a company, they produce spirulina in the large scale. So we have very good experience and of working on this particular area. And when we visited the Madurai, I can remember that we visited that my collaborator took us in some village, and the villagers they presented the use of spirulina in the form of some drama, and they shows that how it give the benefit to the day-to-day life, not only to have the nutritional supplement, but also some kind of health problem like gouts and other things they recovered by using this spirulina. So this is it is a very useful material that is that can be used for human consumption. And benefits is that it has the 50 to 70% of protein, more than the beef and chicken and soybean. 8 essential and 10 non-essential amino acids are present there. Gamma linolenic, beta carotene, linolenic, then arachidonic acid, then vitamin B12, iron, calcium, phosphorus, and phycocyanin, a pigment protein complex that is found only in the blue-green algae. So this is not only used as a food supplement, but used as a natural color, as a source of natural color. That is the major advantage of this. It also gives the help to produce some kind of natural color, which is used for different purpose, which doesn't have much of this harmful effect to the human beings. And it is used as a food supplement for the aquaculture, aquarium, and poultry industry, that it finds very useful material for this purpose. Spirulina is used as food dietary supplement and nutritional supplement and natural health product, because I told you it has some nutrient that the medicinal value, so it can be used as a health product. Some of its components are also used as food coloring agent in Japan. This is the natural color, this is usually permitted. We know most of the inorganic color that is not good for our human health. So the certain cosmetics also use the spirulina as a active ingredients, because some cosmetics, particularly I can tell you lipsticks, that is the women that mostly use, if it is made of synthetic materials, sometimes it has some effect on the skin, and not only skin, that helps the health to a great extent. So natural color gives better, because it doesn't have much of harmful effect to the human beings. So this has lot of applications as far human beings are concerned. Now one important aspect I can tell you that if it looks very nice when you see it under microscope, it looks very nice. You can easily visualize from here, and the Anthrospira, the species is a free-floating filamentous cyanobacteria characterized by cylindrical multicellular trichomes in an open left-hand helix. Can you see that how it that helical formations is there? It is like this. So you can see, if you see under microscope, it looks very nice, and this occurs naturally in tropical and subtropical lakes with a high pH and high concentration of carbonate and bicarbonate, because you know that this is a mostly the autotrophic organism, and they fix the carbon dioxide in the form of some organic molecules. So the availability, the largest commercial producer of spirulina are located in United States, Thailand, India, Taiwan, China, Bangladesh, Pakistan, Burma, what you call Myanmar, and Greece and Chile. The cost of production of spirulina dietary product in India ranges from 600 to 100 rupees per kg of the product, and you can see how this is grow in the open pond. This is open pond, it can grow like this. Now mode of growth, these tiny green spiral coils harvest the energy of the sun and growing as a treasure of bioavailable nutrient. So this is like this autotrophic growth I told you. This use the carbon dioxide. We have three type of growth. We have autotrophic growth, we have mixotrophic growth, we have hexotrophic growth. Now if you look at the autotrophic growth, an organism that is able to form the nutritional organic substances from the simple inorganic substance like carbon dioxide, then we call it autotrophic. Autotrophic means they use the carbon dioxide as a bodybuilding materials. The heterotrophic means an organism deriving from the nutritional requirement from the complex organic substances. They use the complex organic substances for the nutritional requirement. So this is called heterotrophs. And mixotrophs, an organism that can be use a mix of different sources of energy and carbon instead of having the single troph mode of the continuum from complete autotroph at one end and to heterotroph in the other end. So they can use both carbon dioxide and the organic compounds for their growth and metabolism. That is we consider as a mixotroph. Now here you see that this is the autotrophic, this is carbon dioxide is fixing here and producing microalgae. The mixotrophic, we use the different nutrients that inorganic and carbon dioxide also we use all this, that is we are saying mixotroph, and here we use the soluble organics, that is we call it heterotrophic organisms. So this is how it can be explained that in a schematic manner. So the methods of cultivation, this required the different type of photobioreactors. Photobioreactors means they utilize the sunlight for their good metabolism. We have different type of photobioreactors. We have plate type of plate, tubular, the annular, and the plate airlift reactors that we have. So plate airlift reactor that we have. Now your plate type of heat exchanger, you can see we can sparge carbon dioxide at the bottom, and we can pass light to both the side, and that algae can grow here. The tubular, we can pass the liquid like this, and it comes out like this, and we put the light source in the maybe in the one way or two ways, whatever we have. In the annular reactor is we find very efficient, but very difficult to handle, because we put the light source at the middle, and liquid goes to the annular space. When it goes, the light will be equally distributed in the surrounding areas. And this is plate airlift. That is how it is work, and so there is the kind of recycle things that you can see that take place inside the system. Now this closed bioreactors, we have two type of photobioreactors that is largely used for the algal biomass production. One is open pond, another is closed bioreactor. Open, when you use open, there is every possibility of getting contamination from the because other algae present in the atmosphere, they may grow as a contaminants. Not only other bacteria also can grow that affects this particular fermentation process, and that is undesirable. But again, that depends on the quality of the media that you use. Now, if you use the media which will not allow other much of the contaminant to grow, then you can use the open pond. Otherwise, it is very difficult to grow. Difficult to use this open pond for the growth of a specific type of algae in the open pond. But closed bioreactor, we have a closed environment, and we have there we can allow one particular type of algae can grow in the closed environment, so that the rate of growth of the organism will be very high. And if you look into the cost aspect, obviously in case of open pond, the cost will be much less. Operational cost also and installation cost both will be less. But when you go to the closed reactor, both the cost will be little bit higher. Now this is like this. The closed photobioreactor looks like the plate type, and this can be programmed in a manner so that as your this is usually located at the roof. As the sun has shifted his position, this automatically this plate shifted in a manner so that most of the light energy can be used for the growth of the algae. Now this is we have both airlift as well as the bubble column reactor. There we can use this column for the growth of the algal cells. This is kind of tubular reactor that also largely used for the algal biomass production. Now in India, as I told you that I have the collaboration with Antenna. There's one group that they have the collaboration with they're the sister concern of one company from Switzerland, and they have this open raceway pond. You can see how it looks. You got different type of raceway pond is there, and they have some kind of protection at the top, so there's some dirt and other things should not fall on the pond. And this is located in the Madurai in the southern India of the southern part of India. Now the commercial producer of spirulina, there are different companies that we have in India as well as in the foreign countries. We have this is the given here, the Sinotech Corporation, the Myanmar microalgae biotech project. There is a lot of companies that have in the different places in the world. And India, we have this company with the Ramsang, that is this Rasa company that is in Karnataka, Om Spirulina unit on Andhra Pradesh, Perry Nutraceuticals that is Tamil Nadu, Dabur group of Sanat products that is Tamil Nadu, NB Laboratories Mumbai. So different companies in India, they produce this spirulina in a large scale, and the spirulina is produced by industry in a large scale in the raceway pond adopted by the mechanized agitator, filtering and drying system with a relatively higher capital investment. In order to cultivate spirulina, one must produce all necessary element which will permit the culture to absorb and utilize this element. This involves the range of suitable temperature, illumination to provide the energy needed for photosynthesis, water and nutrients. Usually grown in autotrophic condition in the open environment. So this is the feature that we have for the industrial spirulina growth, and this spirulina producing farm choose the tropical region so that the requirement of temperature range 30 to 37 degrees centigrade in the daytime and 25 to 30 degrees centigrade in the night time. The requirement rich source of water, that is water is the main source for this cultivation. Water is required. 10 hours illumination, because again if you look at some western country that their illumination is drastically reduced in some particular season. So in the tropical country is suitable. The reason is that that illumination is more as compared to some of the western country. So here that is why we find that India is a very good place for the cultivation of the algae. And 10 hours illumination minimum required for the growth of the algae. Now low humidity, low wind. Regarding the nutrient source, one must supply the organic and inorganic sources of carbon, nitrogen and minerals, because I told you that whenever we grow any kind of microorganisms, we require proper carbon source, nitrogen source, minerals and vitamin. So whatever things is required, that we might have to find out use the pure material, but we can use some cheaper source so that the food supplement can be given in a way so that your organism growth can grow in a proper way. And tank construction for spirulina. Building spirulina cultivation tank is very important, since many parameters have to be considered in tank construction to ensure the efficient spirulina culturing. Any watertight open containers can be used to grow spirulina, provided it will resist the corrosion and be non-toxic. Its shape is immaterial, although the sharp angle should be avoided to facilitate the agitation or cleaning. That the spirulina can grow in tarpaulin, the transparent or a permanent cement tank. That then most current commercial farm over last 30 years have been designed with shallow raceway pond circulated with a paddle wheeler, because I shall show you the raceway pond. Raceway pond is very easily we can explain that raceway pond is very nice. It is like this. We have, so we can have a paddle here. We can put a paddle here. With this help of this paddle, we can rotate this, so that we can with the help of hand or with the help of pump, we can rotate it. So as you rotate, the liquid will flow this way and it will go right like this. It will keep on rotating like this. So the pond vary in size 5,000 square meter, that is 1.2 acres or larger. Water depth typically is 15 to 25 centimeter. Here I want to point out that we did some experiment in our lab. We find out that if because I was talking about the flat panel reactors like this, you have seen the flat panels, and question comes, if you have light source here, question comes, this is light source, and what should be the thickness, up to which thickness your light can penetrate and helps for the growth of the microorganism. And it has been observed that in our research work we have observed that the depth of 3 centimeter is very good for the growth of the organism. So this we shall have to keep in mind. But here in case of this roseway pond, they found that the typical depth of the water that should be 15 to 25 centimeter. So and they required more capital investment than the lake farm and operate higher efficiency and quality control. So this is the raceway pond. I told you how it looks. That is something similar to, you can see how it is that they are building up the raceway pond. They have a partition wall here, and this is one tank, 18 square meter, produces approximately 150 gram of spirulina per day. This is kind of raceway pond that they have been constructed. Now this is the integrated spirulina farming, that how it works. This is outdoor pond that is located like this. The tube system, the closed reactor that we have. So both the things we can use, and then this it comes to the harvesting plant. Here I want to tell one very important thing, that that in the algae it has been observed that 20 to 30% cost is spent for harvesting purpose. Harvesting, that means the separation of the cells from the liquid, and since the size of the algae is not very big size, so in the filter you have to take the things through the filtration process, and that is so. And we find that if you use the natural settling process, that it remains. You have to use the special technique, that separation technique, so that your algae can settle down very easily. We found the electroflocculation technique is very effective for the separation of the algal cells. Now this harvesting plants, we take it out, then we dry this product, and or we can extract for the plants. It can use the fish pond and product plant. So it can be marketed in the different way. Dry spirulina powder or crystals, it can be used in the form of tablets, or finished good natural color, vitamin, minerals for pharmaceuticals, decoloring colored protein, and also it can be used as face feed and shrimp and their prawn products for the growth of fish. The product it can use. So it has, if you look at the integrated form, is very useful, that we use the carbon dioxide present in the atmosphere. We can fix in the form of algal cell mass, and then it can be used for different purpose. So we have resources, then growth, then harvest, then processing, and then we have the product. This is the steps involved. Now flowchart for spirulina production. We have the nutrient salt. We have 600 meter depth groundwater. We have culture media. Then we run pond with agitator. Then we have collection. This wash, concentrate dewatering, spray drying, sieving, quality inspection, spirulina powder, pressing, spirulina tablet, packaging and storage. Here also powder, you can do the packaging and storage. And this is algae filament spirulina, and that propagation, first, second tier, we can do that. We can have this product. This is how spirulina that production take place in the industry. Now spirulina, we required very media composition. You can see most of the minerals is contains that carbonate, bicarbonate, nitrate, phosphate, sulfate, chloride, sodium, potassium, magnesium, calcium, iron, total dissolved solid density, alkalinity. Then the temperature 20 degrees centigrade usually preferred. That is required that. Now media for spirulina cultivation. The spirulina they usually grow in alkaline pH, and this is brackish water. Then the culture media provides all essential material for the growth of spirulina. Then It composed of sodium carbonate. This sodium carbonate also used as a carbon source, a source of nitrogen, phosphorus and iron and trace metals. Only the food grade chemicals are used. That the choice of chemicals, because if we don't use the food grade chemicals, then this cannot be used as a food product. So choice of chemicals and concentrations depends on the cost and compatibility of the chemicals with the raw materials. The cost of the nutrients accounts to 15 to 25% of the total production cost. The strain selection, that is very important as far as spirulina cultivation is concerned. The major determinant is the selection of strain for commercial production are growth rate, biochemical composition, resistance to mechanical and physiological stress. A wide variety of species strain that spirulina have been screened by several people by various countries. Continuous mass production of a particular strain depends on the suitability and stability under the prevailing condition of the farm environment. Now, scale up of that spirulina cultivation, culture is scale up from the mother culture that prepared in the lab. The scale up followed roughly 5:1 dilution ratio. I told you that that usually 5 to 10% we use. Here we use a little bit higher. It goes as high as 20% through the successive volume up to the culture that required culture in the production pond. The second mode of operation, culture expansion to the entire volume of the production pond, can be done from seedling in the concentration 1 gram per liter. Through careful manipulation of the nutrient concentration, useful natural predator, it has been possible to maintain the monoalgal culture even during the initial period of inoculation. The scaling up process in this stage, where the contamination by other algae or bacteria poses the greatest problem because of the different dilute nature of the spirulina inoculum. There is a direct relationship between the density of spirulina in the culture and density of contaminants. Contamination by green algae is high when the initial density of the inoculum is low. Because this is also very important factor, that the inoculum volume plays very important role for this any fermentation process. If your inoculum is less, this affects the fermentation process to a great extent. Conversely, this amount of contamination decreases as the spirulina culture build up in density. So effect of density, the light intensity plays very important role. We find 30 to 40 kilolux. This find the normal optimal operation for spirulina. Outdoor algae culture exposed to two rhythm of dark and light rhythm. The rhythm 1 is the relatively fast. It is induced the mixing of the pond, which results the turbulent flow of the culture and dictating the frequency of the life cycle. In this cycle, the algal cell is shifted from the full solar radiation when located in the upper culture surface and completely darkness when reaches the bottom culture, usually in the depth of 12 to 15 centimeter. Other relatively slower region is the range of solar irradiation during the day and the sunrise to sunset. The two light cycle impose the unique physiological rhythm on the adaptation and acclimatization of outdoor algal cells to light. So the effect of light, I don't like to tell in details, because light, as you know, algae gives some kind of pigments and it gives some kind of shading effect. So that as it grows very high, the density increases, light conversion efficiency that decreases to a great extent. So that gives the self-shading effect. That is the major problem with that. So we cannot grow up to a certain level. So the light conversion efficiency automatically decreases. And pH also plays very important. I told you the alkaline pH plays very important role in the algal cultivation process. pH adjusted by increasing carbon dioxide by the addition of carbonate salts. The main area of losing carbon dioxide are exchange in the atmosphere and precipitation of calcium carbonate lose to the part of the media is not recycled back to the pond. Now harvesting, I told you this is that we spent a good amount of money for the harvesting process, and this process, if we want to look at the economy of the process, we shall have to make the harvesting process little bit cheaper. Then we've observed that electroflocculation technique is found a little bit cheaper, and it can be used effectively for the separation for the harvesting of the yeast cells. And drying, you can see that how this yeast cells, the skinner, and when you take the yeast cell, this comes in the form of this solid mass. It looks like this, and then we shall have to filter it, and after that the synthetic cloth and mesh of 30 to 50 microns is preferred for filtering media. Supporting filtration cloth is fine net, will accelerate somewhat the filtration and protect the clothes against the rupturing. So this is the things that we have. And then the slurry obtained about 8 to 10% dry weight after filtration was with the potable filtered water. This step is used for washing the excess salt from the biomass. Its amount 20 to 30% of dry weight. Final dewatering accomplished by pressing the biomass enclosed in a piece of filtrate cloth, a strong cloth plus a strong cotton cloth, either by hand or by any kind of press. So this is that is used, and you see that after when you press it, you get the algae in this dry form. It is this is not 100% dry, but it is we take out a lot of moisture from it. And then this we can put it in different forms. You can see we can put it some kind of mechanical device, and through which we can make it in the form of thread. You can see, and then if you keep it in the sun, you can dry it, or you can keep it in the dryer. It can dry it very easily. And so sun dry is one of the most economical system for the small project. In this, the concentrated biomass is spread thinner in the food grade polythene sheet and kept under the sunlight for 4 to 5 hours. After drying, the flakes is collected and stored clean and moistureless and opaque container. The grinding process is done simply by mixer grinder. So this is like this. This is the how the drying operation that is taking place in the different places, and here I can show you the different forms, how the spirulina has been marketed. It forms marketed in the form of flakes, in the form of powder, in the form of tablets, in the form of candies, in the form of capsules. So in conclusion, I want to tell that the spirulina is quite successful venture. As per technology is concerned, we find it has largely used throughout the world. Different companies are coming out for marketing this product, and it is successfully they are producing in the both mostly in the open raceway pond, and problem rise on a couple of areas. One is light penetration problem, another is light intensity, another is your harvesting problem. So if we can, a contamination problem, that is another problem that we use. Growth characteristics of the organism, that also plays very important role. Now if we can address this, we can make the process much cheaper. Thank you very much.